Alright guys, welcome back to the spring semester exam review. This is part 4. This is going to cover all of topic 7. If you need to see the other topics, please refer to the other videos for those other topics. Let's get started. Number 19, it says to write a word problem that is modeled by the function y equals 1500 times 1.082 to the x power. So if you recall that 1500, that's our initial amount. That's what we start with. This is our b, okay? B, that is our, excuse me, that is our growth or decay factor. So the fact that b is greater than 1 tells us that this is growth, okay? So if you want to make a note, when b is greater than 1, it's growth. When b is less than 1, it is decay. Now, b is separated into 1 plus r. So in this case, 1 plus r equals 1.082. So that means r is equal to 0.082, which you could model as 8.2%. Okay? So if we wanted to talk about an investment, that's what this equation is used for a lot. You could say that, you could say something like you invest, we're going to say $1,500 because usually this is going with money. You invest $1,500 in an account that grows 8.2% annually, because this rate is usually annually. So you could write something like that. This is not the only correct answer to this problem, but this is just an example of what you could write. Looking at number 20, it says Sandy drops a ball from a height of 24 meters. Its height on each successive bounce is 1/4 of its height on the previous bounce. Write an exponential function to model its height on the nth bounce. So we can actually use exponential decay on this because we have an initial of 24. So we have an a value of 24, which I forgot this on the last problem. We can use y equals a times 1 plus r to the t power. I forgot to put that. So our initial is 24 meters. We can say our rate of, we're going to say decay because the height is going down, the height is decreasing. It's going by 1/4, okay? So since decreasing, we're going to say it's negative, and 1/4 is the same as 0.25. And then on the nth bounce, that's our time, so we're going to say our time is, we're just going to say n. So we can say this is y equals 24. Now remember, this in here, all right, it can either be written as 1 plus r, or it can be written as b. So we can either say 1 minus 0.025, or what I'm going to put is I'm going to put 0.025. I wrote that incorrectly. My bad, guys. 0.25. And so that would be 0.75 to the n power. Now, on your test, it may look like that, or it may look like that. Okay, so just be aware that these are both the same. Looking at 25, it says a mathlete solved the following log equation: log 4 of x plus 5 plus log 4 x plus 2 equals 1, and he got x equals -1 and x equals -6. And it says how reasonable are those solutions. So basically, what they're asking is, are these solutions, are they extraneous or are they real solutions? And so we just need to double check both of these solutions. So what we're going to do is we're going to plug in -1 back into the equation, and then we're going to plug in -6 back into the equation. When we plug them in, if they equal 1, then it works. If it doesn't equal 1, then it's an extraneous solution. So we're going to go over to our calculator, and we're going to type in our logs. Remember, alpha window 5 is how you put in a log with a base. So log 4, instead of x plus 5, we're going to say negative 1. So negative 1 plus 5. Oh, I need to delete that. There we go. And then we're going to say plus log 4. And again, instead of x plus 2, we're going to say negative 1 plus 2. And if this gets us 1, then this is a reasonable solution. And it does. So negative 1 is reasonable. So let's see what happens when we do negative 6. So all I have to do is I'm just going to copy this equation. And I'm going to replace both of these negative 1s with negative 6s. So instead of negative 1, we have negative 6. And then, oops, excuse me. And then same thing on this one. Instead of negative 1, we have negative 6. And let's see if this works. So that gave me an error message. So that means negative 6 is extraneous because it didn't work. We don't care what the answer is instead. In this case, there's not one. If it doesn't equal, in this case, 1, then it doesn't work. So negative 1 is reasonable. Negative 6 is extraneous. Looking at number 26, it's asking us to solve 5 to the x plus 2 plus 3 equals 50. So what we're going to do is we're going to start by subtracting 3. And we're going to get 5 to the x plus 2 is equal to 47. And now what I'm going to do is I'm going to convert this back to a log. And so my base is 5, so this is going to be a log of 5. And then remember, my answer becomes inside the log, and my exponent comes out here. Okay, so we have log 5 of 47 equals x plus 2. All I have to do is subtract 2, and we can get our solution for x. So we're going to go, again, oops, excuse me, wrong button. We're going to go alpha window 5. Again, we're going to do log 5 of 47, and then we were subtracting 2. We get x is equal to 0.392. We'll just go to 3 decimal places. Okay, so again, remember the rule of converting from exponent to log and back. Refer to, refer to, I believe it's your 7.5 notes for that. All right, looking at 21, it's saying, what is the domain and range of the function log base 2, that is a 2 of x? And so we know that domain for logs is always x is greater than your h value. In this case, we don't have an h, so we're going to say x is greater than 0. And then range for all log functions is all real numbers. This never changes. Range never changes. Domain, remember, is always going to be x is greater than your h value. Okay? Now, 22 is asking us to write this in log form. So I have a base of 3, so this is going to be log base 3. And then remember my exponent and answer switch, so the 81 is going to be in my log, and 4 is going to come by itself. Looking at 27, it says, what is the solution of 7 to the x equals 49 to the 4th? So a little trick here. We know 49 is the same as 7 squared, so we can rewrite this as 7 to the x equals 7 squared to the 4th. Okay, because again, all I did was rewrite 49 as 7 squared. And then I know with exponent rules that I'm going to multiply these two together. So I know that 7 to the x is equal to 7, 2 times 4 is 8. And so that means these two exponents equal each other, so that means x equals 8. Looking at 28, it's asking us to solve natural log of x plus 6 equals 5. So what we can do is I know that natural logs have a base of e. And so we're going to flip this around. We're going to convert this back to exponential form. So we're going to say e, my answer is 5. So e to the 5th is equal to x plus 6. And then we will subtract 6 from both sides. And then we will get our answer for x. So in your calculator, to get the e, we're going to do second ln. E, it was to the 5th power. And then we're going to subtract 6. We're going to get x is equal to 142, we'll say 0.413. It'll specify on your exam how many decimal places. if it's an answer you have to type in. But for this, we'll do 142.413. All right, last three problems. Number 23 says, describe how y equals negative 1/2 times 3 to the x relates to the parent function y equals 3 to the x. So basically, this is asking what are the transformations going on. So I see, compared to my parent function, I have a negative and I have a 1/2 in front of my, in front of my exponent. So that negative means I am going to reflect across the x-axis. We always reflect across the x-axis, not the y in this class. And then that 1/2 is a vertical compression by 1/2. Remember, stretches are when your a value, this number in front, is greater than 1. And a compression is when that number is between 0 and 1, like 1/2. 24 is a very similar question. It's asking us how y equals log base 2 of x plus 2 minus 3 relates to the parent function y equals log 2 of x. So again, asking us what the transformations are. So compared to my parent function, I have this plus 2 inside the parentheses, and then I have a minus 3 outside the parentheses. So since the plus 2 is inside my parentheses, I know that that is an h value, and so I know that means that direction is left or right. Since it's plus 2 and h is backwards, we're going to move left 2. That's what this graph is doing. It's moving left 2. And then that negative 3 is outside the parentheses, so that means that is a k value. So that means since it's negative, we're going to move down 3. And those are my only two things different from my parent function, so those are my only two transformations. Now lastly, number 29, it says the graph of f of x equals natural log of x minus 1 is shown below. So that's this graph right here. It wants us to write the equation of the vertical asymptote for the function. So remember, vertical asymptotes run up and down, horizontal asymptotes run left and right. Since this is a log, we only have a vertical asymptote. So vertical asymptotes are always x equals. If we were doing a horizontal asymptote, that would be y equals. And in this case, looking at my graph, all right, looking at for a vertical line that this graph appears to be avoiding, it's right here at 1. If you see it's right at 1, it's, just curving away. So we're going to say that asymptote is at x equals 1. I also know it's x equals 1 because this right here tells me I am moving right 1 unit. And for my parent function, the vertical asymptote is at x equals 0. So moving to the right 1 would be x equals 1. Now that is going to wrap up the review for the spring semester exam review. So if you have any questions over any of these topics, please refer back to your notes, refer to the videos, refer to any of those resources you have, and also ask your teacher. Good luck on your semester exam. We know you're going to do fantastic.